Right, thank you for coming. So today we'll be talking about the topic here, steering. Yeah, a topic here called steering traffic in OSPF. So here's the big topic here is the OSPF, and then we'll be playing something with interface calls. Okay, so yeah, that's how it works. So let's start. So the agenda today will be we'll do a review talking about OSPF and then talking about interface calls. So this is the main menu for today. Yeah, interface calls and path selection based on the cost. So because the metric for OSPF is the cost here. Okay. So that's the agenda. So let's do some review. Okay, for those who are new, we are GLC, Garda Lintas Cakrawala. We are based in Bandung, Indonesia. We are doing training and IT consulting for several technologies or vendors like MikroTik, Ubiquiti, Linux. Okay. We also develop a web-based application. In this case, is GLC Radius Manager and other application as well. So my name is Achmad Mardiansyah. Okay, oops, something wrong here. Yeah, I'm based in Bandung as well. So I'm Linux user, MikroTik user, Ubiquiti user, Cisco user, whatever user, PHP user, Python user. So I'm a consultant. So we usually use several technologies from different vendors. Okay, so if you have LinkedIn, and then we can connect here. Okay. And this is our past experience, mostly related to network. Yeah, so building network from ground up. So from zero to do something. If you want to change something in the the network, like an upgrade or something, we can do that as well. Okay. Yeah, thank you very much for coming. So if you don't mind, you can introduce yourself in the group chat so that we know where you are from. Prerequisite, we assume you already know several stuff in order to understand the content. At least you know TCP/IP, you know what the IP address is, you know the subnetting and so on and so forth. You have experience how to use MikroTik, otherwise you'll get lost. You know what's the difference between routing protocol and the routed protocol. Routing protocol is like RIP, OSPF, BGP. Routed protocol is like IP. Other like NetBEUI, for Samba. Okay. Yeah, those are routing and routed protocols. Okay, so let's do a review. As you know, in networking, we have 7 OSI layers. So actually, it's a group of functions. So every layer has its own function. Okay, layer 1, layer 2, layer 3. Layer 3 is for end-to-end communication. So that's why we need addressing there. And also, layer 4 is for host-to-host communication. Yeah, to make sure that the data is arrived successfully. So for that, we have an algorithm to make sure the data is complete. So either in layer 4 you have a TCP or UDP. And layer 4, 5, 6, and 7. Okay, so we're not talking more on that. Yeah. And here is the encapsulation. So the data from upper layer will not talk to the other layer. So one layer talk to the other layer on different hosts. Okay. So the way we do communication is we are passing the data and then from one layer to the other layer, and then on the other layers is we are sending all of them. Okay. So after you get the data in one layer, that layer will add header related to that layer. Okay, so we have a data, segment, packet, and then frame, and then a bit. Okay, so as you can see, we have an encapsulation here. It's a big encapsulation overhead. Okay, it's like this one. This is your data. Okay, this is what you really send. Yeah, so it's quite big. Right. And then here we have a routing and router. Routing is the process, router is the hardware. Okay, so usually we do a drawing a typical network connection. We have what is it? A physical topology, and then where this device connect to that device. So those kind of connectivity will be done in the what is it? Physical topology. And then after you set up the physical topology, you set up logical topology. Here you're focusing more on layer 3 so that you will not see layer 2 devices here because all of them are layer 3. Okay, this subnet connected to that subnet and so on and so forth. And then this is how the routing table looks like. Okay, so actually you have two, actually there are three. Yeah, you have a destination, and then you have a gateway. Actually here you have a distance. Okay, distance. Right. And then this is an example of if one packet arrive at the router, and then what will happen. Okay, so the router will do routing lookup and then checking every records whether it match or not with the incoming packet. Okay, so in MikroTik, this is where the routing table lookup happens in routing decision. So after the pre-routing chain, okay, in the firewall, so you have pre-routing, and then you have a routing decision, and then you have forward, and then post-routing. Okay. Yeah, as I said, this is how the routing works. Yeah. Yeah, together with the administrative distance. So actually, this is the gateway. This is destination, and then here's the distance. Yeah. Okay. So you can see it here, here, and here. Here's the distance. And then based on this table, we go to here. Okay. So this is the where you want to go, destination. Here's the gateway, and then here's the distance. Okay, so this is live from MikroTik. Okay, this is the command that you can type for displaying the information. Okay, so this is administrative distance. Yeah, from a different type of record. Yeah, so every record must have administrative distance, and then the way you configure the administrative distance depends on the vendor. Okay, some vendor use this number, some vendor use that number. Okay, so this is the MikroTik routing table. Okay, so the way you configure the routing table, you can use static routing. It means that you have to log in to every router and then configure them manually. Or you can use dynamic routing. So still, you need to log into every router to configure the dynamic routing, but you will not configure the routing entry. Okay, you will not configure this particular record. Okay, so this is routing record, this is routing entry, this is routing entry. So this routing entry will be done automatically here. Okay. Yeah. Oops. Okay. So and then you need to know that the asymmetric routing happens. Yeah. Okay, from A to B. The path from A to B is not similar from B to A. So this is what we say, something we can do configuration. We can do bandwidth steering or traffic steering with this asymmetric routing. Okay. Okay, so next is the OSPF, open shortest path. Yeah, open shortest path. Dynamic routing. Yeah. Yeah. Dynamic, again, OSPF is dynamic routing protocol. It's got link state. So dynamic means, yeah, it's opposite of static, right? Oops, sorry. Yeah, it's a link state with Dijkstra algorithm. Yeah, it has a hierarchical and then using area, and then it's classified as IGP. Okay, so all router must have the same AS number. It has protocol number 89. Many people using it. It has support load balancing, and then here, some things to consider is it requires CPU processing, and then it's more complex if you have lots of it has more options to configure. Okay. So this is autonomous system number. So if you have AS is a collection of routers. Okay. So this is you have AS number 1, and this is AS number 2, AS number 3, number 4. Okay. And then they connect to each other here and here, right? And yeah, so you run BGP over here. Okay, so you can see it's a green line here, it's the BGP. But inside the AS, you're running IGP, internal gateway protocol. Okay, so here, either RIP, OSPF, ISIS, or GRP, or whatever. So again, OSPF is for internal. Okay. This is OSPF work. It's very easy. So you just activate the OSPF in one router, and then on the other router you need to activate the OSPF. Yeah. What you need to do is very, very simple. Create the instance. Once the instance is done, you set up the area. Okay. So this is the area, for example. And then here you define the interface where it's listening. Okay, you can define the networks, network type here, just put it standard. Okay, and that's it. You can run the OSPF. So our topic is lies here. Okay, so at the which is the cause. Okay, so that's the cause. So we are playing with the cause here in order to steering the traffic. Okay. So and here's the OSPF area. So as you can see, yeah, this is the ASBR. Okay, so it will connect to other AS. Other AS. Yeah, you connect to other AS here. And then, yeah, so, and then this is the area 0. Okay, and then this is the area 1, non-zero. Okay, and then here's area 2. So area means collection of network. AS is collection of router. Okay, so router. One AS is connected to AS. Okay, so network becomes area. So here we have ABR. Why is ABR? Area border router, because it's connected to different area. So this is also ABR connected to different area here and here. Okay. IR has no. Is it still recording? Oh yeah. IR means connect to is connected to one single area. So IR, yeah, AVR, ASVR. Okay, simple as that. And then in our topology, it will be look like this. Okay, so here we have router 86. So this is ASVR. Okay. And then it will connect to, so all of them are area 0, so make it easy. So this is area, router 1, this is router 2, this is router 21, this is router 22, and then this is how they connect. Okay, through cables. We don't use wireless here. All of them are connected through, oops, sorry, my handwriting is quite difficult to control using this one. Okay, so this is ether 6, here also ether 6. Okay, here's ether 3, here's also ether 3. So all of them will connect to each other. Okay, so from router 86 to router 21, you have 2 or 3. Okay, so here we have router 21. Yeah, and then router 1. Okay, and then router 2, and then router 22. Okay, here they can connect directly to this, connect directly to this, here, here, and here. Okay, so from router 21 to router, maybe a different color. Yeah. So from router 21 to router 86, okay, they will go. Yeah. Oh, they have a connection also here. Okay, so from router 21 to router 86, yeah. So the path will be from here and from here. Okay. Why? Because the cost will be minimal. Okay. And what about the return? Same thing. Same thing happen. Yeah, from here to here to this. Okay. Yeah. Is it possible that outgoing and incoming we can steer it? It can be steered? Yes, it's possible. So that we can say like for return, follow this path. Okay. Yeah, by applying the cost. Okay. So where do you put the mic? The cost? It's very easy. Here. Okay. So you can start your OSPF, and then on your and on your interface template here. Okay. On this interface. Yeah, so we have OSPF interface. So it's a grouping. Yeah, I can say it's a grouping so that you can put more than one interface here. Okay. Interface 6, and then here's you define the area, blah, blah, blah. And then you put here the cost associated to this. This cost is associated to this one. Okay, so all interface here, okay, will have same cost. And then the way we determine the cost, will be accumulated on the path. Okay. And then you can see it here. The results is, this is the routing table, right? And then here, as I said, is the indicator, okay? So O here means OSPF. And then these routing entries will, yeah, it's a given from OSPF neighbor, and then here's the gateway and so on and so forth. So from the routing point of view, it's the same routing table. Okay, you have a destination, you have gateway, and then you have distance. But the way it is appeared on routing table is by OSPF routing. Okay, so if you click here, double click, and then you see the details on OSPF tab, you will see the routing metric and then the OSPF area. Is it intra area or extra area? Intra area means internal. Okay. Yeah, so here it is. So the way we configure the router is defining the cost. So for example, from router 1, here's the cost 10, here's the cost 10. Okay, from the other side is also 10 here. Okay, here's another 10, another 10, 10, 10, 10, 10. So we can, the way we set up the cost is on interface, on output interface only. Okay, so anything else? No. Oops, I forgot to erase the drawing. Sorry. Yeah. Okay. So yeah, I think that's all. So after this, we will do some demo. Yeah. So let's see. Yeah. Yeah. Before we go, we do the demo. So if you are interested, just come to our training. Yeah. You will get training from experienced teacher. Not only learning materials, but also sharing experience, best practice, and networking. Yeah, again, for those who are looking for recording, yes, yeah, if you want to do feedback, here's the link. Further events will be available on our website. So at the moment, the event is on webinar, which is done in every Thursday evening. Okay, Facebook page is available here. Slide will be uploaded on Slideshare. Okay, we have a group discussion on Discord, and the recording here will be available on YouTube. All right, so I will do the, okay, let's do setup for OSPF. If you have questions, and then please say something in the group chat. Okay. Is it working? Oh, yeah. Okay, so yeah, when we do topology, oops, when we do configurations, the one important thing is the topology. Okay, so here it is. Here's the topology. Oops. Okay, so what we want to do is to set up OSPF from here to router 86. Okay, let's do that. So I will log in to router 86 first. Okay, so this is 86. So I have, so first we set up the filters. Okay, so this is the output filter. Okay, and then input filter. Okay, both of them are same. So we just allow everything. So we are not playing with the filter. Perhaps in the future, in the next webinar, we will discuss the routing filter, because the routing filter here is different compared to the previous version, which is version 6. Okay, so routing filter is done, instant is done. Okay, so you have in and out, and then the area. Oh, area, we don't have any area. Instance 1, area 0. Okay, done. And then we can set up an interface. Okay, interface is 6. Okay, network is blah, blah, blah. Cost is 10, for example, and done. Okay, so that's for router 86. Okay, we don't see any neighbors here yet. So let's do, and not this one. Let's do OSPF in router 1. Where's the router 1? Oh, okay. I think I've closed it. Wait a moment, okay? Where is it? Ah, yeah, here it is. So this is router 1. Okay, let's check the filter. Routing filter, OSPF in, OSPF out. Okay, so we just allow everything. Okay, so should be fine. Oops, sorry. And then we set up the area. Here we have area 0. Okay, from instance 1. So in OSPF you can have more than one instance. Yes, it's possible. Yeah. And then here, let's say we can set up an interface template. Okay, so I'm using ether 6 for that. Network is broadcast. So here I'm not using this. Okay, and then also we put the interface for loopback. Cost is 10, for example. Then start. So hopefully everything is okay. Here I will put also the loopback address on interface. Okay, loopback, and then see neighbors. Oh, sorry, maybe there's a typo. Area 0. Okay, on instance number 1. Yeah, and then interface is 6. Broadcast, no authentication, then we should be able to go now. And here interface is interface 1, the router ID, OSPF out, OSPF in. Oh, okay. Okay, so we put ether 6 and loopback in our template. Oh no, authentication key. And then here's the interface we are running on. Area that the neighbor is empty. Okay, so you can see instance 1. Our address is 2. Okay. So router 1 is okay. Oops. let's check. Do we have? Oh, we don't have the address, IP address of 168.86.86. Sorry, that's why. Right. So it should be okay by now. Yeah, IP address is very important. Okay, so make sure you have IP address on that particular interface. Yeah, so this is 86.1 and here's 86.86. Yeah, it should be okay by now, and then we can see each other. Yeah, yeah. Okay, done. So we do the same thing in router 2. So same thing, routing, filter. Oh, okay, they don't have the filter. Yeah, we can add. Okay. And then here's for out, we can do copy. Okay, done. And then we do routing, OSPF. Okay, the version 3 instance 1. Oh, okay, make sure the IP address is there. Okay, here's the loopback. Then here's the ether6. Okay. Okay, done. IP address is done. Name is instance1. Okay, done. So as you can see, oh, okay, we can already see the neighbors. Oh, here's what we can see. Okay. Yeah. Oh, okay. So, but here we were playing. This is from the training, OSPF training, routing training. So we need to adjust a little bit for our webinar here to make sure all of them are using array 0. Okay. So here we use loopback and then ether6. Oh, let's put all of them. And then ether3. Yeah, is that correct? Yeah, to go down, it's ether2. Okay. So it's ether2. And then to the left is ether3. So we just put all of them in one go. Okay, we need to adjust the naming. Okay, so instance 1, area 0 here. And then this one is instance 1, area 11. Okay. Put here, look back, ether6, ether2, ether3. Instance area is area instance 1, area 0. Networks, we can just eliminate that. Cost here is 10, not passive. Okay. And now authentication. Okay, all are similar. Then once you're done, we can see the neighbor here. Okay, it's 86 and 1. Oh, I forgot to add here, to add more interfaces like ether2 and ether3. Okay, so as you can see, all of them are connected to each other, see? Okay, so from the 86, we can only see 2 routers. Okay, and then from router 1, we can see router 86 and 2. Again, we are referring to this topology. Okay. 2 and 3, 2 and 3, yeah. And then we have router 21 and 22. So we can see it here. Let's do the routing filter to check. Okay, the routing filter. Okay, everything is good. So we will configure the OSPF. So with OSPF, we can add instance 1, version 2 for IPv4. All of them are same. Routing table is main, sorry. Router ID, okay, we can do it automatically. OSPF out and OSPF in, right? Done. As simple as that. And then next is the area. So instance 1, area 0. Okay. Oh, we have to make sure the IP addresses. Oh, okay. There is no IP addresses at the moment. Well, we can set up. Okay, so it's 11.1.21.21/24. It's on Ether 2. Okay, and then next is 11.21.22.21/24 on Ether 3. Yeah, okay, it's done. Oh, we forgot to add the loopback. Okay, there's no loopback here, so we need to add. It's very easy. You go to bridge, loopback. Okay, it's done. And then we add the IP address on that 10.0.0.21. It's a /32, so we don't need the network, and the network is still the same as the IP address. Okay, so this is how the loopback IP address looks like. Okay, so the net address and network are similar. So at the moment, we cannot see any neighbors because we haven't added the interface for OSPF. So that we can add. Okay, so we can add Ether 2. Okay, we can add Ether 3. We can add loopback. Yes. Area is area 0, network broadcast, priority 1, for example, cost is 10. Okay, no authentication, blah, 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 and it's done. Should be okay. We will see. Oh, okay. See, we can see other routers. In this case is the router 1 here. Can double click and then check here is the ID. So this ID belongs to router 1. Right, so that was router 21. Now router 22. Let's check. Do they have, oh, okay, they have loopback already. Done, that's good. Check the IP address, yes. Okay, let's check the IP address also here. Okay, loopback is not loopback, yes, it's okay. So Ether 2, Ether 3, Ether 4 go down, and Ether 1. Ether 1 is for OIM, operation and maintenance. So it's not used for traffic, just for maintenance, so that we can log in today to the router. That's the function of Ether 1. Okay, so looks like it's okay here. Okay, so the IP address is done. Okay, so that's the checklist. Yeah. Again, I will. Okay, let's do the checklist first. Is the routing filter is done. Next checklist is IP address is done. Okay, good. Next is instance is done. Okay. Okay, so instance 1, version 2, router ID, table name main, output filter, input filter. Okay, it's here. And then Yeah, the area, no need. Okay, instance is done, then is the area. Okay. Okay, let's rename this one. Instance 1, area 11. Okay, here, instance 1, area 0. Okay, should be done successfully. Okay, all of them, I will delete all of them. Okay, that's okay. We can create new one, which, so we are 22, which is this one here. Okay, so what we select are router ether 2, okay, ether 3, loopback, yes. And the networks, no need. Cost is 10, priority, whatever. That's okay. And then check. So that in router 22, we can see 2 routers, yeah. So this is from router 2, this is from router 21. Right, so what do we see on routing tables? So as you can see on router 86, okay, on router 86, it's got IP address of loopback here, 10.0.0.86, so that we can see IP routes, okay, 10.0.0.86, or this one, yeah. Okay, so as you can see, so this is the IP address of 86, okay, and then here's the IP address of it, and then located on loopback interface. Yeah, and then on router 21 here, so this is router 21, this one, and this is router 86 is this one. Okay, so on router 21, we can see that there is a route here to 10.0.0.86 via here. Okay, 11, 21, 22. So it goes this way. And then usually this way and goes to 86. Right. So what about the metric? Okay, that's the thing that we need to find out. Okay, let's see. But you can just double click that and then see. So distance is 110. So 110. Okay, we will calculate why is it happening? Why the distance is a 10? Okay, so that we can check the way we go from 21 to 86. We will check one by one the interface. So on router 21, we can check here the template. Okay, so everything goes to ether 2, ether 3, and loop back. The cost is 10. Okay, and then on router 22, you can check ether 2, ether 3. Yeah, ether 2 that goes up, ether 3 that goes left. It's the cost is 10. Okay, and then we check in the router 2. Let's see. Okay, so here we have the loop back. Okay, and then the cost is 10. Okay, and then here we can see cost is 1. Oops, we need to check. Okay, here's cost is 10 on ether 6. Okay, let's see let's see the cost on router 21 IP route, and then here 10.0086. Metric is 40. So there is an error here on router 86. Okay, so that's why the metric is very high. So what about how's the calculation? So it's 40. Okay, so let's calculate the 40. How it looks like. Oops. Single page. Okay. Okay, so let's count. So here is 10, right? 10, 10, 10, and then on here is 10. The loopback interface also has interface, right? So yeah, it's counted. So it's 10, 10, 10, and 10. So 10 multiplied by 4 equals to 40. Yeah, so it's similar to what we have here. Okay, so 40. Right, so let's change something. Okay, let's change something on the path. Okay, I will change on router 2, for example. So all of them here will be 20. As you can see. So if I change here 20, it will change the number from 40 to 50. So how it looks like, okay. So let's do the calculation. So here is 10, is 10, here is 20, and then here is 10. Okay, so all of them are 50. Okay. So as you can see, so from router 21 goes to router 86. So this is 86. It goes through router 22 here, 22. How do we know? Because the last part here is 22. Okay, it's 22. Okay, so but I want to change so that that particular traffic goes through up here, goes to router 1. Well, we can do that by adding more cost here, for example. Make it 50. Okay, and then change to 80. Okay, still goes to router 22, maybe 100. Oh, not here, perhaps. So here is 10. Oh yeah, still 130. Okay, still 10, but let's do something in the router 22, yeah. So for router 22, I'll change the cost to 500. So it says here 530. Yeah, this one still go to the cost here, 530. Something not correct here. Anybody? Okay, so let's do the trace route. Slash tool trace route 10.0.0.86. Yeah, still go through via router 22. What about router 1? Router 1 goes to, so if router 1 wants to go to that particular traffic entry, 86 here, it goes directly to, yeah, here, 86, so it's a direct connection. Okay. And what about the distance? The distance is 20. Yeah, so it's 20, 10 here, and another 10 here. That's 20. What if I want to change to other routes, for example? Okay, so let's do here. Let's do routing OSPF. Okay, interface template. Routing OSPF face template. Oh, okay, let me duplicate this one. Okay, so I will split the template, okay? Yeah, is it possible? Yeah, it's possible. Yeah. So as you can see, this template is for iter6. This template is for loopback iter2, iter3. This is what I like in version 7. So here I can put 900 or 9,000. Okay, so let's see the traffic. So as you can see, if I want to go to 86, I will go to 2.2, so which is router 2. Okay, if I change this one, okay, let me do it again. So it means that we are rerouting the traffic. Okay, again, traffic to 8632 here goes via router 2 because we put here the cost 9,000. If we change to 10, okay, so it will go directly to here. Okay, let me check again. So I want to go this, and then here's the gateway. Okay, why? Because the cost is 20. Now, if I change 9,000, what will happen? Okay, change. So the destination is still the same, but the gateway is different now. Okay, because the OSPF that is calculated through this path is 30 compared to 9,000 here. So I think it's the same case. So we need to increase the distance, the cost. Okay, so here through 22, Okay, let's add to 9999. Oops, too many. Oh, let's do the splitting. Okay, so this is for iterative only. And this is without iterative. Okay, so we split them. Okay, so iter 3, 10, cool. Iter 2 that goes up is 9999. Okay, I'll see that. Yeah, it should be okay. So the total cost here is, wow, it's very high. So it means that the other route should be higher than this. Strange, yeah? Okay, I think we need to split on this one, which we'll do next time, yeah? I think time is up. Sorry for that. Well, I think that's all for today. At least we can show you how the bandwidth steering looks like. Okay. For example, in router 1 here, what we do is we change the cost at output interface. Okay, so what we can control is the output interface. Yeah, we cannot control the input traffic. So we engineer the traffic by outbound traffic. Okay, by steering the outbound traffic. Okay, with the outbound traffic, we are expecting that the incoming traffic will be going on a different path. Okay, so I think that's all. So sorry for this one. Perhaps we will do troubleshooting in the next webinar. Again, thank you very much for coming, and then see you in the next webinar. Okay, again, thank you, and
Thank you.
have a nice day.